then let's get started. This is Stefan.
This is Steve.
We're here from Benify to talk about how we do and have done continuous delivery for almost over 10 years. So this is the presentation today. We'll start off a short introduction about us, our company and our product, and then go into the more nitty-gritty details on how we do continuous delivery, and talk a bit about our processes, more details, and then a short review and outlook.
Okay, so two short slides about us. I'm Stefan. I've been now that doesn't seem to work, so let's go with that one. I've been a software developer at Benify for a bit over 5 years now. Previously, I've worked at other product companies, 2 other product companies for another 5 years. And basically, I tried to sum up what I stand for, and it's basically everything around clean and code and solutions. So as in clean code, you probably all of you know that book. Hopefully you've read it. Also, like in clean solutions, and there I think more about a kitchen tool that is easy to use, looks really nice, is easy to clean, and hopefully takes not a lot of space in the kitchen. And also everything about solutions that you can solve with code. And that is, of course, at my work, but also another thing that I've been doing in my free time is a Raspberry Pi-based device that helps you to control your temperature in your remote holiday home. So you have basically a SMS interface that you can start and stop your heating and control the temperature and so on. Apart from that, I love traveling. So this is me coding Java on Java, which is a really nice experience. And since I grew up in Switzerland, of course, I like the Alps and the mountains in general. So this is me on the highest point of Madeira, having a great overview of a lot of ocean, which is hard to get in the Alps, actually.
Yeah, this is me. As you can see, I like dolphins and barbecuing. I've been working in this industry since the late 90s now, almost exclusively as a software tester. I love software testing because I find it very creative and challenging. Love going in and trying to find all these outliers and weird cases. You know, the investigating part of it all. I've been working at rather large organizations, but also very small ones, Scrum teams, and more waterfall organizations. As I said, I love barbecuing and gardening, and sometimes I can laugh a bit too loud.
Loud, yes, too loud, no, never.
So let's talk a bit about our company. We were founded in 2004 here in Sweden. We're one of the largest companies when it comes to benefits and compensations. We exist in 9 European countries, 10, and to date we have almost 900,000 end users here in Europe using our system. It's a rewards and personalized benefits system. It allows employers to raise awareness of existing benefits. It also allows the employee to know what benefits he or she is entitled to. It's a system to easily view, order benefits, view pay slips and company information. Benefits can range from anything from pensions, insurances, to wellness contribution, which is quite big here in Sweden, to even company-sponsored events. You might even be using the system without knowing it, because many custom installations, they're tailored to the company with the look and feel for that company. So it can even be a part of your company's intranet solution today. So the architecture is very common. We have a platform, Java-based. On top of that, we have a configuration layer that creates these special customized solutions for the end users. And that could be Java code, it could be JSP resources, such as images, for instance. And everything in that content layer can be deployed without a restart of the system, thereby allowing these releases to, well, be made in a continuous fashion as well. But during this presentation, since both me and Stefan work in the platform, we will focus on the platform part of the product. So let's go into how we have been using continuous delivery for over 10 years. This graph goes back to well, it's 6 years. And you see releases to production split on month per month. And as you can see, the average is, well, it's actually over 1 per day. And the trend currently is that we stabilize more and more around 1 per day. You see less high peaks and valleys as you go forward in this graph. Some valleys are quite interesting since we're a Swedish-based company. You see that in July, for instance, we do not have many releases to production.
Okay, so let's dig down a bit deeper into how our continuous delivery process looks like. Basically, on a high level, once the developer considers the code done, it will end up in our CI environment, where all the builds get built and the tests get run and so on. You then have the possibility to deploy it on a staging or test environment if required. Once the build is green, we have a code review step where the code will get reviewed by a peer developer. If that gets passed, it gets integrated into our main branch and is ready to be released. So we're going to look at the processes involved a little bit. But first, let's look at the main tools, since whenever you do processes, you're going to need tool support, and it's often easier to start on that end. So we're basically using Git for versioning control system and Jira to track issues and manage issues. And I put up here our basic Jira workflow that we're now going to go through, which basically maps the processes that we have in place to support our continuous delivery process. And there an issue or a change request would somehow end up in Jira. There would happen some requirement analysis, some more investigation, some verification, which is outside the development group. And then at some point it will get assigned to a developer, and that's where it starts for us as developers. So you would pick it up, it would go into progress step. Once you consider your code done, it would go into a code review step, and finally it would end up in a committed step. And that's when a code change is considered ready to be released. And so that's basically what I call the blue process here, which is the core software development process where the developers are involved.
There are, of course, other state transitions, but we try to just indicate the important ones here.
Exactly, that one is simplified. The other important process that we're going to cover is here the green process, which is when we actually push changes to production, which we will go more into in the following slides. And then at the end of the workflow, of course, close the feedback loop. It's up to the stakeholder to actually validate the issue and either be satisfied with it, push it into closed, or reopen it and start around. So the other tool that I mentioned is Git to support version control. And there we have a quite simple workflow. We use the master branch as an integration and release branch. And for the daily work of all developers, you would branch off, create short-living branches where you fix your issues, and then once you consider it ready, open a merge request, you get a code review, and it will get integrated into the master build. Then if we have bigger projects, bigger stories, bigger features that have to get implemented, we would usually start a longer living branch at the start of the project, and which serves as an integration branch during the life cycle of the project, and the developers involved would branch off from that longer living branch, do their daily work, and integrate back into that longer living branch. If we show this thing a bit more graphically again, we have our master branch, which is the integration branch and release branch. Let's assume an initial commit. Then a developer gets assigned to a bug issue that he has to fix, so he would create a new branch, would fix the thing there and do the testing and all that. Once he's happy, we'll open a merge request, we'll get a code review from a peer developer, it will get integrated into the master branch, and usually the same night we'll get a release and it will get pushed out to the production. Similar story for an enhancement. You create the branch, you investigate and fix the issue or implement the enhancement, might take up several commits that survive, and then again merge request, you do the code review, it gets integrated into the master branch, and for doing the next release we'll get pushed out to production. A bit a different story for those bigger projects. You would create the longer living branch, which for feature 1 in this case. That of course branches from the master branch originally. The developers would then on a daily basis or for every task or issue create separate branches, do the development there, do the code review, it gets integrated into the longer living branch again. That story continues as the project lives on. From time to time, of course, you're gonna update from the master branch, do the rebase. If you're working on features that can be put back onto master branch without affecting the existing solution, you can use feature toggles to shut them off. Then, of course, you can switch back. Yeah, question? Meaning what? So you mean when a fix gets merged into master?
Is actually ported to master. Now this code, I assume it's a manual merge, right? Or a pull request.
Exactly, yeah.
So have you ever considered like cascading this automatically, automating this process?
I mean that will, whenever you do the rebasing from the feature 1 branch, you will get all those changes. So we don't push out this.
Because from the graph I don't see any arrows between bug 1 and the feature integration.
But the bug 1 branch is dead.
Yeah, it's pull requested to master.
Exactly, and then it's dead. It disappears since you have.
The pull request is manual.
Exactly. The merge request is you create it manually, and then another guy does the code review, it gets integrated into master.
Because, for example, in Stash, you can actually auto-cascade branches, and pull requests are being opened like automatically, and if all goes well, they will match automatically.
Okay. Okay, but since for us the master branch is like the one and only the branch that reflects reality. So what we want to do is move it into there, and then it's up to all the longer living branches to fetch the changes. So. So where were we? So for the longer living branch, you would rebase from time to time. Both branches continue to live, and at some point there will be the release date for feature 1. At that point, it will be merged back into master. That branch will die, and in the next release, you're going to get all the nice features from feature 1 on the production system. So now let's look at what I call the blue process, which is the core software development process. What does it involve for the developers? First step is usually to understand the requirements, talk to any stakeholder, any other persons that can help you in understanding and find a good and solid solution. Depending on the size of the issue, you would take a discussion development internally to find a nice technical design or fit it nicely into the existing design. If it's UI changes, we have a small UI team that will help us developers following the UI guidelines and making the UI experience good for the end users. Of course, the core thing is to actually do the coding. That involves both implementing and either writing automated tests and or doing manual testing in your own development environment. Once you consider your code done, you submit the merge request, which will become a code review request for a peer developer. That might end up in some discussions. You maybe want to involve another guy. Once the code gets accepted, it gets merged onto the master branch. Jenkins will then pick it up and do one more build to make sure that it's stable, and send any emails to the involved developers if the build turns out not to be stable. And at the end of the day, usually for us, it will end up on production then. We're going to look at that later. Actually now. So yeah, so is that clear? Or okay, then let's go to the green process, the release process. Before going into that one, I'll show you a bit more detailed how our production landscape looks like. We have quite a simple stack, a database, which is MySQL for us, an application server, Tomcat in our case, and that's it basically. Not much more requirements from the production environment. Now, if you remember, we are currently present in 9 countries all over Europe, and quite early on, we decided for several reasons to run separate instances in every country. So that means right now we are running 9 completely different production instances. They look exactly identical, same stack, database, and application server. So what does that mean if you want to release? Well, you're going to have to release into 9 different production sites. That sounds like a lot of manual work, right? You don't want to do that manually. So also quite early on, we decided to go for a master-slave architecture. So we put one of these instances, the Swedish one, since that's where we started, consider it as the master instance, and degrading or assuming that all others take the role of slave instances. now the release process is then split up into two parts. The first part will be pushing your build onto the master instance, and the second part will be updating all your slave instances based on the master instance. So let's first look at the first part, how to push changes into the master instance. That is done by our CI environment, Jenkins for us as well. We set up a release pipeline that takes care of all the steps. So the only thing that is manual is actually triggering the deployment. Jenkins would then assemble and upload the WAR file into a specific folder on the production environment on the master instance. And Jenkins would also assemble and send the release notes to interested parties. Assembling the release notes is via the REST API, via Jira. So just collecting all the issues that are in the committed state from the previous Jira workflow. On the production instance, once the WAR file is uploaded, we have a cron job that periodically checks for new WAR files and just redeploys into our Tomcat instance. And up to you as a release manager who pressed the button in Jenkins will then be to check the log file for any errors, ensure that the application has come up, and so on, and take action, of course, if something didn't go wrong. Now, since we release like more than 30 times per month, eventually something will go wrong. You will not survive 1 year, like 360 releases, with nothing ever going wrong. So, but that's part of it. The second part is once our master instance is updated, what happens with all the slave instances? How does that part work? So again, we have our master instance. On the other side, we have a number of slave instances. Now, if we look at these instances more closer, we can see that they look identical. Big parts of it actually are identical. So the web app is exactly the same WAR file being deployed on all of them. However, the data in the database is, of course, different. Like I'd say 95% of the data, 99% of the data is different. So the only thing that is common to all instances is a very thin layer of common data, typically language resources, language translations. You would want to have the English translation available on all instances.
You have data that is country-specific, such as benefits and also users.
Users, companies, yeah. Exactly. So what you end up is actually instance-specific data, which is a huge part of the database, and a thin layer of common data. So when we want to update our slave database, our slave instances, what happens every night in our case is that they simply call home, that is calling master instance, asking, do you have any new WAR file? How is it with the data? Any differences? If there is something new available, it will be downloaded and deployed automatically. And that's it. So that ensures for us that basically on a daily basis we get identical applications on all our production instances. And currently we are present in Western Europe only, so there are no really time zone challenges yet. But for the future, that will be an interesting challenge, for sure. Any questions here?
Do you have a short downtime when you deploy?
Exactly. Yeah. So and that will usually be outside business hours, and that is accepted by our customers. So that's one of the preconditions. Exactly. Yeah, the synchronizing has been in place for say 7, 8 years. So yeah, it's written on our own. Okay, that's it for our processes. Next step, review and outlook.
Yeah.
So if we want to see how well does it work for us, we asked the question, are we happy with it? Can we somehow see whether it has worked fine for us? And in order to verify that, I've taken a number of indicators, mostly growth indicators, but not only, you're going to see. The number of developers, we have like 6 years ago, we were 3 developers. Now we have scaled up to 14 developers. So of course, minor adjustments as we go, but basically the same process. Better tool support, I would say. That is a difference. But it worked fine. Number of features, interesting question. What we did here was to find a way to measure or estimate the number of features that we've built. Is that we took the since we have a web application, we took the number of URL mappings that our application actually responds to, has implementations for. And that number has grown from about 450, 500 in beginning of 2010 to around 1,400, a bit over 1,400 in the beginning of this year. So here again, it's somewhere a bit above linear growth, so looks good. Next thing, number of end users, you mentioned it.
Almost 900,000.
900,000 right now. 6 years ago, we were around 200, 250,000. So there again, healthy growth, I would say. Geographical markets, I think 5, 6 years ago, we were present mainly in Sweden, maybe starting off with the second country. So now we're present in 9 countries. So again, healthy growth. But actually, it's not only about growth. It's also about shrinkage. And shrinkage, that's in the number of applications that we actually develop and support. We had, in the beginning, we had 3 completely separate applications. It was, apart from the web application, it was a monitoring application, and it was an administration application. And these 2 applications were fat clients, so Swing-based, that you had to install. And as we grew, both the organization and the number of features and the end users, it became harder and harder to maintain these separate code bases to make sure that they are consistent in behavior. Also, permission management was a challenge, making sure that you get the same permissions consistently over all applications. So I think the monitoring application, it died first, since that's a bit easier to do in the web application. The administration application died around 4 years ago when we decided to migrate all functionality into the web application. So we have one single application that covers all our functionality. So yeah, we are happy. Yeah.
So yeah, the picture above depicts a common definition of continuous delivery, where you code and then you automatically execute your unit tests and automatically execute your integration tests and so on until you reach a state where you manually deploy to production. And this is very similar to what we've done. And a logical next step would be to go for full continuous deployment, where you automatically deploy the checked-in code to production. For each check-in, you automatically update your production. And we've chosen not to go that way. It's a conscious decision from our part for several reasons that we'll talk about now. First, we have database changes. Today, those are manual, and a positive thing with that is it's a quality gate, where people that have the alter table permission, they will do a review of the alterations prior to executing this. So all the DB schema changes will be reviewed by these people that have alter table permissions. Another thing is that it's a manual click means that someone is responsible for that release to production. If something happens, it's very good to have a person sitting there to be able to revert or troubleshoot what has actually happened. And that might be a good thing. It's a very good thing. It could be, for instance, that if the WAR file fails to upload, it could be anything really, and having a person sitting there being responsible to quickly take actions is a very positive thing. As you said earlier, deploying to production means downtime for us. So we need to restrict when we do these deployments. We can't do it during business hours, for instance. We need to limit that. We have an ongoing project to scale our app server horizontally, which will decrease downtime and enable us to release during working hours, but we will still try to limit that. So these are a couple of factors that limits us from going to full continuous deployment.
So can you use it too? We tried to come up with a few considerations when thinking about introducing or using continuous delivery. I think one precondition is that you're running software as a service. If you have a product that is installed locally on the customer site, in theory there is nothing that prevents you from continuously pushing out changes to that to those production instances. However, the customer, I don't believe they will buy that. They will actually accept that you are pushing changes to their production instances without them having control over it. So I believe in practice it's much easier to have a web-based deployment. I've also heard the argument that manual testing. Sorry, but we have manual tests, so I don't think we can do continuous delivery since there is your manual step. I don't agree. I believe that manual testing will slow down your time to production. Basically, it will make it slower, but it will not prevent you from continuously building stuff and making it production ready. And finally, last but not least, I would say the mindset. The tools and the processes are one thing, but I believe the mindset in your organization is the most important thing. And that goes both for developers, but also for the management. For developers, they have to be aware that push to the integration branch, whatever it's called, means it can get released at any time. And you have to get used to that. I had quite a hard time getting used to it in the first few weeks when I started at Benify. The first evenings I came home, I was a bit anxious, can say. But you get used to it, and once you get over it, you will love it. I love it for sure. For management, I think it's important to, since you are continuously pushing out changes, you will continuously get feedback from your end users. And it's important in your resource planning for the developers to actually be able to react on that feedback. Because what good is continuously getting feedback if you cannot react on it? So that's an important point. On the app side, for me as a developer, I really love the fact that it's much less a mental to be released burden. If you have like releases twice a year, you kind of collect up all the things that you fix or implement, and you're getting more and more anxious for that day when the big release will happen, and you don't know how will it play with each other. Of course, you have testing phases and so on, but still at the end of the day, all your changes and all changes of your colleagues will together be deployed, and it's kind of, you feel kind of uncertain, like what will happen. Whereas here it's like every day it gets pushed, so like every day I can mentally check off the things that I've implemented or pushed to production yesterday, which is really nice. For the management side, I think a nice thing is that if you get acute bugs, or you get reports from your customers, oh, something is not working, we have to do something as fast as possible. You can do it. You can just put a developer on it, fix it, and release it. You won't have to take meetings deciding, should we schedule another release before the next planned release? Should we put it in the next release? What are the consequences? Will we have to pay any fines, or all this kind of stuff? It's not there. You just need someone actually looking at the problem, fixing it, and as soon as it's fixed, it can be deployed, basically. And yeah, and I mean, I mentioned it a bit before, the Big Bang release problem, that goes, of course, for both developers and management. There will be no Big Bang releases, but it's in a very agile way. It's a small iterative things getting pushed to production.
Yeah, that's it.
That's it?
Yep.
So, any questions?
Do you have any requirements regarding performance or such? Do you have time to perform load tests, or do you just push things like in production, or do you have time to do that?
No, if you have the requirement of load tests, of course you have to do that before. I mean, you have to do that before you actually push it into the master branch. I mean, if you have a certain load test criteria that you have to fulfill, your code is not considered done before you actually fulfill it. So if we have these kind of things, yeah, do it, of course, before you push.
Your build pipes for, say, feature branch and a master branch, are they exactly the same? You can perform integration tests, unit test, integration tests?
Yeah, so we have a set of builds in Jenkins that are set up for the master branch, and then it's a plugin that will just, if it's up to every branch. Actually, we have a naming convention. So if you call your branch, if you prefix it with Devil, the Jenkins plugin will pick it up and will set up the exact same build pipeline for your separate branch. So yeah, you will run all the same tests on your branches. Yeah.
Do you ever have to roll back production releases, or do you move forward because of it?
So the basic strategy is going forward.
Yeah. Specifically for the database changes, do you ever have to realize that all the table things that you did manually, which has been taking new data, have to roll back? What do you do with the data that's been created in the meantime with this?
Yeah, so if you are at that point, there is no way back, simply. We don't build, when we do DDL changes on the database or data migrations, we are aware of the fact that there is no way back. So,
This is, say, one application, 145.
yeah.
Do you think this would work if you should go for a microservice architecture? Certain components would be
Yeah. Sorry? Yeah, good question. I mean, I believe we have had these discussions like about splitting it up into several parts. I think an important part there is that your organization has to reflect your code structure. So if you split it up, it would be a bigger step than just splitting it up. You have to think about, okay, how do you organize your teams? Who will be responsible for what parts? And I guess, would it scale or not? Certainly you can make it scale, I would say, but probably a challenge.
We probably need to change tools and processes, but I would say that the biggest change is already done. We have the mindset already for continuous delivery. So we probably could make it work.
What do you think? Okay.
All right then.
Okay.
Thanks.
Yeah, coffee break is sponsored, so have a look at that slide.